Let's start with concave mirrors. So for a concave mirror, it's curved like you're looking into a spoon as you're eating your soup. Any incident light ray that is parallel to this thing called the principal axis here, parallel to that central axis, any light ray that's parallel to that will reflect through what's called the focus. And the distance of the focus from the mirror just depends on the curvature of that mirror. So any ray that comes in parallel will reflect through the focus. In the same way, any ray that's incident that comes through the focus and hits the mirror will reflect in a parallel direction, so parallel to that central axis or the principal axis. If you've got rays coming in and all heading through the focal point or the focus of the mirror, they will all reflect parallel to the central axis. And this is the basis for the headlamp in your car. Your light source is a lamp right in front of a mirror here. It sends light out in all directions and they all get reflected in a parallel direction, so they all point out the front in the one direction so you can see where you're going. The reason it's called a converging mirror is that any light that comes in parallel will all reflect through the focus, so they converge. And this example is, we can use an example for solar hot water heating. So you've got the light rays coming in here, hit a concave mirror, the light is reflected all into one little point here, which is where your pipe with your water might be, so you're going to heat your water. This is how we're going to draw ray diagrams for a concave mirror. Here's our mirror here, the curved surface. I'm just replacing it with a black line. We can assume that most of the situations that we're thinking of have such a small amount of curvature that we can assume that the light is pretty much reflecting all for one surface. It is an approximation, but it'll do for now. So we choose a point on the object, usually the top of the object. We draw a ray which is parallel to the central axis, and then that ray, of course, reflects through the focus. If we draw a ray through the focus, the reflected ray is parallel to the central axis. And of course, where those reflected rays appear to agree that they come from, it's where the reflected rays meet, that is where our image is. So in this case, our image is inverted, it's upside down, it's diminished, it's smaller, and it's real, which means we could project it onto a screen. This will always happen when you have an object which is further out than the focal point for a concave mirror. Just another example for a concave mirror, which is with an object closer to the mirror than the focus. We again draw or choose a point in the object, draw a ray parallel to the central axis. The reflected ray travels through the focus. This next bit is a little bit different. Instead of drawing a ray through the focus and have it reflect, we draw a ray as if it were coming through the focus. So there it is. It's coming from the object towards the mirror, but it's directed as if it were coming from the focus. Then it would reflect parallel. And where do those two rays appear to come from? Behind the mirror. The object is upright, it's bigger, which means it's enlarged, and it's virtual, it's behind the mirror. My question is, what kind of image is formed with an object exactly at the focus of a concave mirror? We'll talk about that in class.